Hi guys, now let's talk about decision making under risk. Now remember, the decision making under risk involves probabilities. So now we're going to work with probabilities. Now it states here that when there are several possible states of nature and the probabilities associated with each possible states are known, the most popular method to choose would be the expected monetary value, or EMV. In probability distribution, there's this thing we call the expected value. An expected value is the measure for central tendency or the mean or average value for a probability distribution. And it's very similar to this as well, except with the term monetary, which means that this is dedicated specifically to measure the monetary value of the payoffs or for the decision making. And since they are technically the same, expected monetary value and the expected value, the formula that we are going to use are also the same. So it is the summation of the payoff for the alternative in state of nature I multiplied by the probability of achieving the payoff for x sub I. So that's just basically it. You multiply the probability of achieving a particular payoff with the payoff itself, and then you sum up all of these products that you have solved, and that will give you the EMV. So remember that this is the EMV per alternative. You don't compute for the EMV for all. Now let us take this one as an example. So it's the similar example we used before. We have the three alternatives: construct a large plant, construct a small plant, or do nothing. And we also have the same states of nature: favorable market and unfavorable market, and below would be the different payoffs. Now let's say that each market outcome has a probability of occurrence of 0.50. Now remember that the formula that we choose is payoff multiplied by the probability of that payoff per alternative. So let's solve first for the construct a large plant alternative. Now the EMV for the large plant is equal to 200,000 multiplied by the probability of 0.5 plus negative 180,000 multiplied by the probability of 0.5. It ultimately gives us the answer of $10,000. Now for the EMV for small plant, we have $100,000 multiplied by the probability of 0.5 plus negative $20,000 multiplied by the probability of 0.5, which gives us the answer of $40,000. Now, the last alternative, do nothing, is 0 multiplied by 0.5 plus 0 multiplied by 0.5 is equal to 0. Now, what is the next step after getting all of these EMVs? We, of course, choose the EMV that is the best or the highest out of all. And that is $40,000, corresponding to the alternative construct a small plant. This time we talked about expected value of perfect information. By the term perfect information, it involves you having to do research, paying your consultants. And why do we need to do this? This is for you to know the value of that additional information added to what you have already researched. So you know that a lot of businessmen would hire consultants, and sometimes we don't know if the rates of these consultants are being a bit overpriced or if it's a bit cheap. So what we want to find out is what would be the cost of having to hire these consultants. Are they charging us the right amount of money or no? Especially when you already have information about certain things and they're just going to add to it. So for example, you have written a thesis, chapters 1 to 5, and you've already written chapters 1 to 3. And so all you need to pay for is chapters 4 to 5 for the other or for the consultant to work on. However, the consultant has charged you a full price of, let's say, $20,000 for chapters 1 to 5, but you already did chapters 1 to 3. So now you want to find out what is the cost of just adding 4 to 5 to what I have already written. And this is how it's like with expected value of perfect information. You are just going to find out the cost of having to add that chapters 4 to 5 to what you have already researched or worked on. Now, EVPI places an upper bound on what you should pay for additional information, like what I have mentioned, while expected value with perfect information is the long-run average return if we have perfect information before a decision is made. Now, with EVWPI, that is the best payoff in the state of nature multiplied by the probability of state of nature. So since it is expected value, we are basically still using the same formula but just plugging in very different numbers. So let's first go to expected value of perfect information. The formula for this one is equal to EVWPI minus best and EMV. So EVWPI is the perfect information. You're just going to subtract what you already know, which is the EMV, which gives you the EVPI. That is the additional information already. Let's consider this one. So the first thing that you need to do, of course, is to construct a decision table. But for this one, notice that we have with perfect information and probabilities added to the different rows. To choose or to determine what is the perfect information, that would be the highest number out of all the possible payoffs per state of nature. It means that with perfect information, you can get the best out of all the alternatives given the different states of nature. Now for the favorable market state of nature, the best option or the best payoff among all of the alternatives is 200,000. And so if you are assuming that you have perfect information and you know everything about that market, about the possibilities or payoffs from that market, you will get a 200,000. However, if it's an unfavorable market, of course, still you're going to choose the best number or the best payoff because you have that perfect information and you choose 0. The next thing to do is to compute for the EVWPI. Now, for the EVWPI, that is 200,000 times 0.5 plus 0 times 0.5, which gives you $100,000. As for the EMV, we have already computed those other things, the 10,000, 40,000, and then the 0. So remember that for EMV, you also multiply the different payoffs by the probability per alternative or per row. Now, the next step to actually computing the EVPI is to subtract. So we have EVPI equal to EVWPI minus maximum EMV, and we have 100,000 minus 40,000 is equal to $60,000. And so the maximum Thomson should pay for the additional information is $60,000. If the consultants would say that the additional information would cost $65,000, he should not pay it. It is overpricing because the additional information is only worth $60,000. So that is EVPI. Now let's talk about expected opportunity loss. You remember this in the earlier videos about opportunity loss, which is basically the cost of not picking the best solutions. So we have here the steps listed. First, construct an opportunity loss table. Second, for each alternative, multiply the opportunity loss by the probability of that loss for each possible outcome and add these together. The minimum EOL will always result in the same decision as maximum EMV. And the minimum EOL will always equal the EVPI. So let's see how this goes. Okay, remember that when you construct an opportunity loss table, it becomes quite different as opposed to the original payoff table, because with this one, you're going to choose the highest payoff and then you use it from which each payoff are subtracted from. So that's why the construct a large plant alternative has a zero payoff for favorable market, because it basically means that would be the opportunity loss if you construct a large plant as opposed to doing the other alternatives. So when you choose the best EOL, it's basically the same as computing for the EMV. So for constructing a large plant, we have 0 multiplied the probability, that is 0.5, plus 180,000 multiplied by 0.5, which gives you $90,000. And then for a small plant, we have $100,000 multiplied by the probability of 0.5 plus $20,000 multiplied by the probability of 0.5 equal to $60,000. As for the third alternative, do nothing, we have 200,000 multiplied by 0.5 plus 0 multiplied by 0.5, which gives us $100,000. Now remember, this is opportunity loss. Now if you're talking about opportunity loss, you choose the least or the minimum number, because that would be the best value or the least cost for you for not choosing the other alternative. Now for the list of EOLs that we have 90,000, 60,000, and 100,000. And out of these three values, or three opportunity loss values, which would be the best EOL? That would be 60,000, because that is the minimum number out of the three. And so that's it for expected opportunity loss and decision making under risk.